So hi everyone, my name is Emilia and I'm an exchange student from Sweden, and this article is actually from the university in Sweden, which is my home university, and it's called Sensor Feedback from a Prosthetic Hand Based on Air-Mediated Pressure from a Hand to Forearm Skin. And here we can see different types of hand prostheses.
Can you send the image from the view? Okay. We can see the view.
Oh, should I start over? Yeah, so the article I'm presenting, it's called Sensor Feedback from Prosthetic Hand Based on Air-Mediated Pressure from a Hand to Forearm Skin. And here we can see different types of hand prosthetics, but common for all of today's prosthetic hands is that they lack sensory feedback. And this is a huge drawback when it comes to prosthetic technology. And there is no commercially available sensory feedback system for artificial limbs. So for non-amputees, sensory feedback is something we don't even think about, and I think all of us take it for granted, even if you use it every day to do different tasks. We determine what we're holding in our hands without even looking, or how much pressure to put on a button. And then if an amputee would have a prosthesis with sensory feedback, it will be amazing for them to experience the real touch again, but also very helpful to, for example, detect if an object is slipping through their hands, and they can adjust the grip force accordingly. So this study, it aims to investigate a non-invasive, simple sensory feedback system, which would provide the user of the prosthetic hand sensory feedback in their arm stump. So for most amputees, they experience phantom limb sensations or even pain, and there is often a map of the phantom hand on the amputee's thumb. And this triggers the area in the somatosensory cortex in the brain, where pressure on specific skin areas evokes sensation from specific fingers from the amputated hand. So they would feel as they still have their hand left, even if they don't. And here's an illustration of how different parts of the brain, they're connected to different body parts, and that's why this can occur. And they did the study on 12 amputees and 20 healthy non-amputees. And they investigated the capacity of the system to immediate detection of touch, discrimination between different levels of pressure, and on the amputees, they also tested the ability to locate the touch. And the system is connecting silicone pads from the prosthetic hand with pads on the amputation stump. And the silicone pads in a tactile display in the amputation stump expand when the corresponding sensor bulb on the prosthesis is touched. And the silicone pads, they had 3 different locations, and here you can see the experimental setup. And to the left, you have for the amputees, and to the right is for the non-amputees. And during the test, they were all blindfolded by eye masks, and their arms were resting comfortably, and they tested the difference in force and location randomly about 30 times. So about the result, the median touch threshold mediated by sensory feedback system did not differ significantly between the 2 groups. And then we had 90% for the amputees and 80% for the non-amputees had correct answers for discrimination between 2 pressure levels. And this is a higher result among the amputees. And that can be explained by rough feedback in terms of quantity of force required for the prosthesis. But the important aspect of this is that you can see easily that it's easier to trigger the hand area in the brain through the phantom map of the sun. And then also the amputees, they could locate touch from 3 different sites correctly 96% of the trials, which is a very promising result. So they made a conceptual model, which you can see here, for how this system could work on a prosthesis. And there you can see the silicone bulbs is on the hand of the prosthesis, and then they're connected to the silicone pads on the thumb, connected to their specific location for each finger. So with this, we can conclude that this simple sensory feedback system has the potential to restore sensory feedback in hand amputees, and therefore it could be a very useful tool to enhance the prosthesis use. And I also believe this could be applied for other body parts. Thank you very much.
Are there any questions to you? Yeah.
Thank you for your presentation. And I have a question about what signal you want to sense about the movement of the human body. What's the signal? Is it electricity, electric current, or?
And this is by touch. So the silicone bulb will like touch the limb. So and then the body's neurons will send the signal to the brain.
Oh.
So this is non-invasive. So this is just touching the skin.
So,
and it would be like feeling from your hands, but because of the phantom map, you could precisely touch the area that would be as same as touching a thumb, for example.
So, if you can sense how strong the force, or you just sense that which part I have touched.
And they could also, they tried different pressure levels. And that's the thing that was, I think here, the amputees, they had 90% correct answers in determining which pressure level. And in this study, they tried 2 different levels.
Okay, thank you.
More questions?
Yeah, thank you for your presentation. Can I know more about the transmission way of the sensory? So the sensor is over the artificial finger?
Yes,
That
there's,
has the touchable?
yeah, you put a silicone on the prosthesis, and then you just touch, and it will transmit make the silicone bulbs in the end of the prosthesis to go bigger and touch your skin.
So there is no nerve between the amputation links and the sensor bulb. How do they connect?
It's just within the system of the prosthesis. So from there, they didn't go through detail what system, but it's just you touch and then the other side will put pressure on the skin. So it's a non-invasive. It's not connected to the nerves in your body.
So the amputee, they need to transfer the feeling, like the touch feeling over your limbs. You just need to transfer yourself.
Yes, exactly. It's the touching, and then like touching, like if I touch my finger, I'll feel, oh, that's my finger. But you do it on the thumb, like you have just nothing. But there's a phantom map, so they still remember. They still have the area in the brain to remember. Oh, this is my thumb. This is my index finger. So by touching the different areas, and it's individual for every amputee. So you have to try it out.
Thank you so much.
Thank you for your presentation. Can I know how fast or it immediately happen that if you like thinking or feeling
I think it's pretty fast. They didn't exactly say how fast, but I think it's almost as fast as normally.
Thank you.
Yeah, thank you. Now, any comments from Japan?
Okay,
Any questions?
excuse me. Thank you for your nice presentation, and I just want to know whether currently what is the status of this, this project? Is it already in the production or not? And do you know any feedback from the person if, let's say, it's already, the prototype is already done?
They're still doing a lot of research on this, and as I showed, they did like a prototype, and they let one person try this, and the person, she felt it was amazing to experience real touch again, and she used it for, I don't remember exactly how long, but they tried it, and they're still trying to improve and develop it more. But it's yet no commercial releases with sensory feedback available.
Thank you.
I'd like to know from the prototype of the sensory feedback, if I expose it to heat, for example, like I expose the prototype to heat, will the phantom be able to tell me that, oh, my finger is burning? Is he able to do that?
This actually, since the thing is the silicone bulbs that touches your skin, so I think the person would still feel it as touch and not heat. So probably they won't feel it.
Okay. Question from Japan. Okay.
Thank you for your presentation. Actually, it's interesting thing, and I feel. My question is, our sense we can detect the hot, the cool, the hard, the soft, and many other things. But is this sensor able to identify or detect such type of feelings or sense like that, or is there any limitation? Thank you.
Like similar to the previous question, I think since the silicone bulbs are touching the skin, it will all feel like touch. So I think touch is the only feeling.
Oh yes, thank you.
Okay. Any question? If not, let's go